I'd like you now to consider a direction of flow problem. This is a problem that has to do with galvanic cells. First of all, let me show you what you're dealing with here. You're dealing with metals, these metal plates or electrodes, and they're each in solutions of aqueous salts. Copper is in a solution of copper 2 nitrate, and lead is in a solution of lead 2 nitrate. So you can see that these are just pointing into the solution, that's X and Y. Then you've got a wire joining the two electrodes, and you have a salt bridge over here as well. And you'll be able to tell the directions of certain things by looking at these arrows that are on here. Now, reading the question, it says that the cell may or may not obey the conventions of a cell diagram, standard cell diagram. What that means is it's not necessarily so that the anode is on the left. It could be on the left or it could be on the right, and you need to be prepared for either eventuality. That means that the reaction could be running in one of two directions. It could be running with the electrons running this way or the electrons running this way, and we need to figure out which way the electrons are going. As well as the direction of electron flow, you're also going to figure out direction of flow of nitrate, direction of flow of the positive ions, species being reduced and oxidized, reducing agent, oxidizing agent, anode and cathode. All of that can be determined from our cell diagram. Well, the first thing we've got to do is we've got to get an appreciation for what's going on with the half reactions. Now we know that the copper is going to have something to do with the copper 2+, and we're going to need to hunt down some values on our reduction potential table. Now I said that we need to do something with copper and copper 2+, and I know this because if I go back to the cell here, I've got copper and I've got copper with 2 nitrates next to it. Now even if you forget to charge on nitrate, you can go to the next question. You can see there it is there. NO3 has a -1 charge. So what that means is if you've got 2 nitrates, that means the copper must be 2+. So we're talking about some sort of interaction between copper and copper 2+ over here. Likewise, we're looking at a interaction between lead and lead 2+, and that's what we're going to be hunting down on our table. Okay, so here's our copper 2+ and copper relationship, which has a E0 of 0.340 volts positive. And the lead one is down here. Pb2 plus 2 electrons gives lead, and that's minus 0.125 volts. Well, the thing is that we know that they can't both be reducing. So one of them is going to have to be oxidizing. So what we do is we leave one as reducing and we flip the other to make it oxidizing. And that's what we'll do in both cases. Alright, so let's take a look at that. Here we go. In this instance, here's what we've done. We've made the copper oxidizing. That is, we've flipped it from being reducing to oxidizing. In so doing, we've made it minus 0.340 volts, because when you make it oxidizing, you have to flip the sign. Just remember, whenever you flip a reaction, flip a reduction, the electrons always move to the other side, and that's what makes it an oxidation. The lead 2+ is still being reduced, and when we total these up, we get a negative E0 cell. What that tells us is if we run the reaction this way with the copper being oxidized and the lead 2+ being reduced, that will be a non-spontaneous process because we're getting a negative value of E0 cell. So what we do is we try the other one. We leave the copper 2+ as being reducing, which means it's just remaining 0.340, and then we flip the lead one and we make it Pb equals Pb2+ plus 2 electrons, and that's going to be positive 0.125 volts, and that's going to give us a positive overall E0 cell value. So now we know which direction the cell is running in. It's running in such a way that copper 2+ is being reduced and lead is being oxidized. Right, now we can put all of that into play and figure out the value of each of these. So first one, direction of electron flow. Here's what we know. We know that the copper 2+ is accepting electrons, and we know that the lead is giving them up. The reason I say that copper 2+ is accepting electrons is because the electrons are on the reactant side. The copper 2+ is being reduced by the electrons. So electrons must be flowing towards the copper electrode. That means they must be flowing towards direction A. The other thing we can look at here is that Pb is turning into Pb2 plus 2 electrons, so the lead is actually giving up 2 electrons. So the 2 electrons that the copper 2 plus is accepting are the very 2 electrons that the lead is giving away, and they're traveling through here in direction A. Nitrate. Nitrate flows through the salt bridge, so the answer is either going to be C or D. With the copper 2 plus, we see what's happening is the copper 2 plus is going to become copper, so it's actually plating onto the copper electrode. The lead, on the other hand, is dissolving, so the Pb is becoming Pb2 plus, and that's going to end up in here. So if the copper 2 plus is plating, that means the copper 2 plus is disappearing. If the copper 2 plus is disappearing, it doesn't need nitrate anymore. Over here we see the lead is turning into lead 2 plus. The lead 2 plus wants the nitrate. So the nitrate will travel from the copper side to the lead side. So it will travel in direction D. And just as an interesting point, we know that if electrons are traveling this way and they're negatively charged, but whatever else is negatively charged has to be traveling in the opposite direction. So whatever anion is traveling through the salt bridge will always be going in the opposite direction to the electrons. So the answer there is D. Next, we want to figure out the direction of flow of copper 2 plus. As I said before, copper 2 plus is plating. Copper 2 plus is turning into copper. That means we're looking in this region, in the copper region, and we have to be talking about E, copper 2 plus flowing towards the copper electrode. The direction of flow of lead 2 plus. As we said, lead is becoming Pb2 plus. That means that this is dissolving. If it's dissolving, it means it's going away from the electrode. We're talking about the lead electrode. It's going to go via direction H. So the answer is H for that one. Right, species being reduced and oxidized. If we're talking about species being reduced and oxidized, we're always talking about one of these reactants, one of these things down here. Now if you want to figure out what's being reduced, look at what's going down in charge. So you've got 2 plus going to 0. So the copper 2 plus is being reduced to copper 0. The species being reduced is copper 2 plus. If you look on the diagram, that would be X. It's actually the copper 2 plus that's in the solution that's being reduced, not the electrode. Species being reduced is copper 2 plus, X. The species being oxidized. Well, the one being oxidized is the one that is gaining charge. So it's going from 0 to plus 2. So the Pb is actually being oxidized, and that's Z. Here's the other way of looking at it for reduced and oxidized. Species that are being reduced are accepting electrons. If they're accepting electrons, electrons will be on the reactant side. So whatever has the electrons on the reactant side will be the species being reduced, in this case copper 2 plus. Lead is going to Pb2 plus 2 electrons. The electrons are on the product side. That's a sign of oxidation. Oxidation is loss of electrons. So electrons on the product side is what you're looking for oxidation. If a lead is being oxidized, so that's going to be Z. The next one's reducing agent and oxidizing agent. These are probably the most difficult to understand, but I'll do my best to explain it to you. The reducing agent is the species that's causing the reduction. So what is causing the Cu2 plus to be reduced? Well, what's causing it to be reduced is whatever is giving up the electrons. Lead is giving up these electrons here. These 2 electrons are the same 2 electrons the copper 2 plus is accepting to become copper. So the copper 2 plus is being reduced by the electrons which came from the lead. The reducing agent is the lead. Another way of looking at this, the reducing agent is always the species being oxidized. Next, so that would be lead, which is Z right here. Okay, oxidizing agent. The oxidizing agent is the species that's causing the oxidation. So we know that Pb is being oxidized, but what's causing it to be oxidized? What's causing it to be oxidized is the copper 2 plus. and it's the copper 2 plus accepting the 2 electrons that the lead is giving up is what's causing the lead to be oxidized. So the oxidizing agent is copper 2 plus, which is X. The other way of looking at that, the oxidizing agent is always the species that is being reduced. The anode is the electrode. So the answer for this one will always be either one of these metal plates here. So the anode is the electrode at which oxidation is occurring, and we can see that the oxidation is occurring at lead, so the anode is Z. The cathode is the electrode at which reduction is occurring, and we see that reduction is occurring over here at the copper. So copper 2 plus is going to copper, that's where the reduction is. The cathode is the electrode, and that's going to be W. So here are some tips that will help you to answer each of the questions. First of all, electron flow. Electrons always flow towards the plating electrode. Nitrate flow. Nitrates always flow towards the cell forming the cation. For cation flow, cations flow toward the plating electrode and away from the dissolving electrode. The species being reduced is always the reactant involved in reduction. The species being oxidized is always the reactant involved in oxidation. The reducing agent is the reactant causing reduction, that is the reactant losing electrons. The oxidizing agent is the reactant causing oxidation, that is the reactant gaining electrons. And the anode and cathode are both electrodes. Anode, the electrode at which oxidation occurs. Cathode, the electrode at which reduction occurs. Remember your mnemonic A, O, C, R, vowels, consonants. Those are good to remember.